Wow, those lights are bright. Thank you so much for joining us here in person and virtually. There's one difference with this session that you may have noticed is that this particular session will not have a Q&A. So there will be a presentation. Feel free to grab the Apple attendees and presenters afterwards. After you exit the room as we get ready for the next session. So thank you so much for joining us. I get to introduce Kelly Conlon and Dan Flynn from Apple joining us today. So please, round of applause.
Yeah, thank you. Hello, everybody. I am Kelly Conlon. Wow, he is right. These lights are bright. I am on the consulting engineering team at Apple. And today our session is called Securing Apple Devices, but we're going to have a little bit of a different message. But before we get into that message, I want to recap a couple of things. So I'm sorry if these slides are repeats, but if you haven't attended our other sessions, we have some information we wanted to cover with you all. So at DubDub this last year, we made some exciting new announcements to our Mac product line. This was a new Mac Studio, Mac Pro, and a new 15-inch MacBook Air. I was really excited about that. All powered by Apple Silicon. So now our entire Mac product line is using Apple Silicon, which is very exciting because it's the latest and the greatest. Additionally, on product updates, last week we announced a new iPhone 15 lineup. All with USB-C, which is also very exciting and probably very heavily requested by users. Additionally, the iPhone 15 now has Dynamic Island, so also very exciting. And then probably the thing I was the most excited about is the AirPod Pros now have USB-C charging as well in the case. And probably the most important, we have some software updates. So as of 2 days ago, on September 18th, iOS 17, iPadOS 17, watchOS are now available. And then starting next week, on September 26th, macOS Sonoma will be available as well. All right, so before we get into the session, I wanted to quickly talk on this slide. I know, again, it's been a repeat. But we really love to show Apple devices being used in school and work. And the reason we're able to have these devices there is because of our great partnerships, but also because of all of you, our users. And we just kind of want to show our gratitude and show that we appreciate our devices being used in these ways, and we can't wait for the continued use cases. All right, so for today's session, yesterday during the keynote, there was a lot of talk about trust, which aligns very similarly to the session we're going to be giving you today. So to kick things off, we're going to be going through establishing trust, the trust lifecycle, implementing a zero trust architecture, and then we're going to follow that up and leave you with some resources as takeaways to kind of continue on the dialogue that we're going to start today. So first up, I'm going to kick things over to my colleague, Dan, to get us rolling.
Great. Thank you, Kelly. So at Apple, we feel very strongly that security of our customers' data is a core responsibility and not just a feature. Secure design principles are implemented at the earliest stage of the design phase. And devices should be also secure by default with little or no additional configuration necessary. Therefore, I propose renaming this session from securing to defending. While Apple product is secure by design and by default, as the saying goes, your threat model is not my threat model. And so what we do to further reduce the attack surface will depend heavily on our use case and business goals, as well as the resources and the capabilities of our adversaries, as we try to increase the cost of the attack up higher than the value of the data it is we are trying to protect. Also, Apple products are very often used in mobile contexts. And so this changes how we determine the integrity and authenticity of our devices as they connect to our institutional resources. And so we're all probably familiar with a user's identity and how to verify that. But it's also of equal importance to verify a device's identity. Let's look about how Apple deployment can be architected in support of the zero trust concept in establishing user and device identity trust. One of the ways we can reasonably verify a user is who they say they are, and that the device that they are using is actually what it says it is. And how can we do that in a mobile context, where the device might have to be provisioned far from our institutional networks? And in today's mobile world, it's very possible that these devices may never actually be on premises. And so let's see how Apple technologies can make this work. The first thing we need to do is verify that the device and the operating system is indeed genuine. And so in the past, what did we used to do? We would often completely wipe the operating system out of the box and reinstall a known good image. Well, today, Secure Boot validates the integrity of the Apple operating system against a hardware-backed root of trust installed during factory fabrication. An online device activation verifies with Apple that the device is a legitimate Apple device and not just something just trying to pretend. And so once we've established device integrity, next we want to add the device to our inventory system of record. In an on-premises environment, this was often accomplished by joining the device to a directory service, typically by binding while connected to an institutional network. But today, that system of record is the MDM. And as you know, using automated device enrollment, the activation process associates the serial number of the device with the mobile device management system that the institution that purchased it, and bootstraps that device into management. To support enrollment from networks beyond our control, the MDM would need to be internet-facing. And therefore, it's important for the MDM to require strong authentication, such as multi-factor authentication, to strongly identify the enrolling user. This can be achieved by configuring the MDM to participate with an identity provider that performs whatever MFA challenge that the institution deems appropriate. During enrollment, an MDM leveraging Managed Device Attestation can be used to independently, cryptographically validate the authenticity of the device. And so in other words, MDM can prove that certain device attributes from the enrolling device, like serial number, operating system version, secure enclave version, and more, are indeed true and not being spoofed. All of this is based on the security and integrity of the device's secure enclave. So even in the unlikely scenario that the application processor is compromised, these attestations are still genuine. Managed Device Attestation has been available since iOS 16 and iPadOS 16, and is now coming to macOS Sonoma. Policies and identities that were historically applied by virtue of joining a directory service are now accomplished through your MDM. And this includes the issuance of client certificate identities. Using the Automatic Certificate Management Environment, otherwise known as ACME for short, the MDM can enroll user identities with secure enclave-bound keys to be used for strong device-bound, phishing-resistant, transparent authentication for services like 802.1x, Kerberos, PKInit, Mutual TLS, VPN, and now Network Relay. Going forward, institutions should strongly consider using network relays in place of VPN for remote access to services. Network Relay provides privacy and security by connecting through a reverse proxy to connect to services without the need to assign the client an IP address or create additional tunneling. And we're going to go into a little bit more on this later. In an on-premises environment, when a directory service user logs in, they get a Kerberos ticket that is used for single sign-on to on-premises resources. Today, the user registers an SSO extension to automate the acquisition of tokens from an identity provider for strong, phishing-resistant, transparent authentication to web services or apps or any other services backed by the IDP. And now, Platform SSO can now be used to dynamically create additional local users on the Mac based on identity provider authentication, as well as manage local macOS authorization roles based on the individual user's IDP group membership. Passkeys are easy to use, standards-based, phishing-resistant credentials that are automatically synced across devices, and will be also supported with managed Apple IDs in iOS 17, iPadOS 17, and macOS Sonoma this fall. And additionally, during registration, passkeys can provide an attestation by a certificate identity enrolled via MDM to ensure that the specific passkey authentication originated from an institutionally owned and managed device. Note that this passkey enterprise attestation does not require support for managed device attestation. So secure boot, activation, and managed device attestation verifies the integrity of the enrolling device, establishing that device trust. Strong user authentication from enrollment all the way through to the user session using technologies such as client certificate identities, SSO extensions, and passkeys, made simple for users with technologies such as Touch ID and Face ID, can be used for phishing-resistant, transparent, and convenient secure user authentication. So now we have established device and user trust during provisioning. But the trust evaluation doesn't stop there. There is ongoing maintenance of this trust determination, known as trust lifecycle. Let's begin with the trust lifecycle for devices. So I'm going to present 3 deployment models, and they're going to differ in ease of development and the security that they provide in the context of zero trust architecture. But first, let me describe the participants in managed device attestation. So most of these participants are probably familiar to you. The Acme server functions much like a SCEP server, and when enrolling a client certificate identity, the device with Acme has a hardware-bound key and a matching certificate issued by that Acme server. When the device uses the resulting identity, it's the relying party that evaluates the certificate the device used. There's many things that can act as a relying party, including a web server, a VPN server, network relay, or even the recipient of an SMIME signed email, for example. And so the first deployment model is what we'll call MDM only. The managed device uses the identity as its MDM client identity when authenticating to the MDM server. The MDM server, in this case, is the only relying party. So this proves the device's identity to the MDM server. The MDM server knows which device it's managing, so everything it's sending only goes to the correct and genuine device. Since this is a single-purpose identity in this model, it uses a certification authority that only the MDM server trusts. And so this model uses an Acme server integrated into the MDM server, similar to how nearly all MDM servers today have an integrated SCEP server. Integration is pretty simple, and you have multiple options. MDMs will begin to support managed device attestation. There's an open source Acme implementation you can use, or you can build your own Acme server from open source. Acme is much simpler protocol to implement than SCEP, and deployment in an organization could be as simple as a single switch inside of your MDM. The second deployment model is what I'll refer to as single evaluation. A single trust evaluation happens when the MDM server issues the certificate. The Acme server knows the device's identity because of the attestation it receives, but it then queries the MDM server to get additional posture information about the device. The result of the trust evaluation determines whether or not to issue the certificate, or possibly what data the CA would put in that issued certificate. If a device's posture deteriorates, the Acme server may be instructed to revoke the certificate, as that's really its only available control. The CA that issues the certificate must be widely trusted by the organization in this model, so the Acme server is likely a standalone piece of an organization's PKI infrastructure, rather than just integrated inside the MDM like the previous model. Deployment requires standing up the Acme server, but the rest is fairly simple. In this model, the relying parties don't need to do anything that they don't already do. This third deployment model I'll call continuous evaluation. In this model, this is the closest to the zero trust ideal. Trust evaluation happens every time the issued certificate is used by the client. So each of the relying parties are doing the trust evaluation themselves. The relying parties collaborate with the MDM server for posture information. Because this happens frequently, the trust evaluation can use the latest information that the MDM server has about that particular device. Each relying party can do its own custom trust evaluation, requiring more stringent requirements, or when that client requires more sensitive access to data. These are both very powerful properties for ease of access and tight security, but it does come at the cost of more effort for deployment. Each relying party may have to be configured in some custom way, including communicating with the MDM server. So these deployment models can vary from the simplest implementation and deployment to the most complex. And the farther you go down the list, the closer you are to a true zero trust architecture. So what's the best deployment model? Well, that's going to be whatever's the simplest one that meets your needs. And I expect that there will be some mixing and matching of these models, even using aspects of all three together, perhaps. And this also lays out a deployment model roadmap. You might add support for an MDM integrated Acme server first, then prepare for integrations with a standalone Acme server, and finally, for additional integrations in the future with all each individual relying parties. So now for some what's new for user identity and access management. So mask relays are a great way to enhance privacy or access private resources. You can send any TCP or UDP connectivity through a relay without needing to modify the backend server. You can chain relay servers together to increase privacy of a connection. And relays are also a great way to access enterprise resources. A relay provides a better user experience, is more performant, and is easier to manage than a VPN. Mask relays use TLS 1.3 to secure all traffic to the proxy, unlike legacy proxy protocols. And Mask uses QUIC, the latest transport protocol, and HTTP 3 to efficiently proxy and multiplex many connections over a single tunnel. And for cases in the networks where QUIC might be blocked, they can fall back to HTTP 2. Relays are an alternative to VPN that can provide a better user experience and are easier to manage by the administrator. A network relay does not require a complex session negotiation and often requires fewer round trips before actual user data is transferred. This ensures that a user's first load of private resource is the most responsive interaction possible. A relay also avoids the use of tunnels, virtual interfaces, and additional IP addresses that are often associated with VPN. You configure a relay using a configuration profile. You define the relay URL for the device to connect to, and just like in VPN profiles, you can use a client certificate identity for authentication to your enterprise servers by referring to that certificate payload in the same profile. You can have the relay apply to specific domains by adding them in the match domains portion of the payload. And since you can configure multiple relays simultaneously, it's easier to access different private domains located in different networks. Enterprise companies that want to use relay servers as an alternative to VPNs have options to use them with their own infrastructure. Vendors have started offering support for network relays as a better alternative to VPNs, and we look forward to seeing how our customers use these new network transport security capabilities. With that, I'm going to hand it back over to Kelly to describe how you can put all this together in your individual organization.
Thank you, Dan. Okay, so before we get too deep into implementation, I wanted to talk a little bit about the core tenets of Zero Trust and how we look at Zero Trust at Apple. So when we're thinking about these, right, these were our actual internally used core tenets for Zero Trust developed by our Apple information security team. And that first one, right, being the true definition of Zero Trust, right, consider everything as hostile, is incredibly critical, and there's a reason it's number one. Additionally, making sure that all of that access is, those decisions are based and rooted in strong identities. Additionally, making sure access is limited to expected or standard behaviors. And then also making sure those decisions, those access decisions, aren't reusable. And then lastly, being flexible, right? Because access privileges do change, right? And you need to be able to adjust and accommodate for that. Okay, so let's start getting into implementation. One of the easiest ways to start using modern auth for MDM enrollment is taking advantage of enrollment customizations. When you're thinking about modern auth, you really want to start using that strong identity practice for anything that's going to be customer facing. So when you're using an enrollment customization, you can integrate with your IDP and ensure that the appropriate users are actually the ones enrolling their devices. So you've got the right Barbie and Barbie world enrolling in your MDM, okay? Additionally, this will make sure that only the approved users are in your MDM or enrolling in your MDM, and we can kind of go over what that would look like. So last spring, we hosted an IT tech camp, and Jamf and Okta actually showcased the use of these enrollment customizations to have a more secure, authenticated workflow for users enrolling in MDM. Additionally, your users, right, we're pretty familiar with this, but if you're not, your users are presented with the IDP login screen that they're used to. They're using those organizational credentials, making things easy and seamless, and continuing on with the day-to-day kind of use cases that they're already familiar with. And now they can do that while enrolling into MDM. Additionally, if your MDM supports it, you can actually prompt for an MFA push on a secondary device to your users, adding in an additional layer of security during that enrollment process. Okay, so let's move on to Managed Device Attestation. Dan's discussed a lot of the specifics around Managed Device Attestation and some of those strategies, but now we have Managed Device Attestation on the Mac. So actually implementing some of these are going to get a lot stronger and additionally a lot more complex if need be. But for having that authentication and trust in that device, you can now do with the Mac with Managed Device Attestation. So when you're using like an Acme attestation, right, to be able to provision those hardware-bound keys based upon those device properties, this creates that hardware-bound keys that are going to be stored on that device keychain. And again, these keys can be used with services like VPN, 802.1x, Kerberos, Exchange, and even MDM. And a couple examples of how that can be used with MDM, with Managed Device Attestation, is what we're going to go over next. So first we have Managed Device Attestation for MDM enrollment and what that would look like. So the first step is the device is going to request to be enrolled into MDM. MDM is going to respond with an attestation request, and then the device is going to send that request back over, provide that over to the MDM. And then the MDM is actually going to validate that attestation with Apple's attestation server. So again, this is how you can implement that device trust into the MDM enrollment. So that previous slide with the enrollment customizations, that was showcasing how you could do that in user trust, and now we can add in that device trust layer. There we go. Okay, so additionally, how can you use Managed Device Attestation for different services? So the MDM server is going to install that Acme profile. That device is going to request from the Acme server for a client certificate. That Acme server is going to then challenge the device to get that attestation certificate. The device will get the attestation certificate from the Apple attestation server. And then that device is going to submit that attestation back to the Acme, or attestation certificate to the Acme server. And then the Acme server is going to validate that attestation certificate and issue a client certificate. This would be the worst drinking game if you're going over certificates and attestation. All right, so let's pivot from attestation and talk about passkeys. So, go back one. There we go. So Declarative Device Management released a new enterprise passkey configuration, enterprise passkey attestation configuration. So this can be used to securely generate a passkey for a user on a device when they visit a specific site or a specific service that's designated within that configuration. So that configuration is going to reference an identity asset, and additionally, if added, a private key can be bound to that device, again, using that Acme server. So this isn't required, but again, it adds in that extra layer of security by using that Acme server because you can take advantage of those hardware-bound keys. Additionally, right, when we're using those hardware-bound keys, this involves things like the secure enclave that's actually going to be doing the generation of that key pair, and that private key is actually going to be cryptographically entangled within the system key, right? So that client certificate identity using Acme is going to allow you to take that extra benefit from the cryptographic angle by using the secure enclave. And again, this is going to prevent the system from exporting those private keys and keeping it entangled on that device. Additionally, right, with passkeys, the associated identity is going to be used to perform a standard WebAuthn attestation with that generated passkey. And then the WebAuthn replying parties can then verify that attestation. And it's going to allow that access to those relevant sites. So let's go over what that looks like. So an organization would configure a device. And then that MDM server is going to send the passkey attestation and configuration and identity asset to the device through, it's going to ensure that that DDM configuration, or Declarative Device Management configuration, actually activates. Upon activation, the identity certificate is provisioned from that corporate certificate authority server, so that corporate CA server. Now, when that user goes to visit a site, right, that site is going to request a passkey for access. And then those relying parties can say whether or not they would accept passkeys generated from that enterprise right or enterprise attestation, or reject all others. So you can have it say, like, I only want passkeys that are generated, right, from Barbie World, and nothing else, no kins allowed. Additionally, that device will then generate a new passkey, attest it to the provisioned identity certificate, and then return it back to the site. The site can then verify that attestation by checking that the device certificate inside the WebAuthn enterprise attestation payload chains back to the CA of that organization. So this is going to allow that attestation, right, for those relying parties, where that passkey is created on that device from that managed or managed by that organization. So in order for this to be possible, right, the relying parties must know which CA to trust from that organization. And this can be achieved a number of ways. You can include or have the org admin upload a copy of the CA to that relying party, where that relying party can then validate the attestation at the time of passkey creation. From that point on, that passkey can be used by that relying party without the need for any further attestation, right? So once it's trusted, it can be trusted. And then passkeys that are actually created in this manner will be stored in the iCloud keychain of that managed Apple ID. And again, this is not hardware attestation. This is attestation for passkeys for enterprise. Okay, so let's take a look at SSO and Platform SSO. So with Platform SSO, making a call to the SSO extension, this allows you to kind of plug into those cloud services and allow those SSO tokens to be taken advantage of in a greater way. Additionally, with Platform SSO 2.0, which was just recently announced at DubDub and will be available on macOS Sonoma, you have just-in-time account creation. So this is great for those shared experiences on Macs, and then with those shared experiences, right, you can now have multi-users, and this is all possible through device registration. So with the SSO registration portion, right, that device would be registered, and then after that, multiple users can be registered without the device having to be re-registered again. But with device and user registration and Platform SSO, it has to be supported by your IDP. So if your IDP does not support device or user registration, you can't take advantage of this. Additionally, with that just-in-time account creation, we now have support for smart cards, which is very exciting for me. And like Dan mentioned, you are now able to use authorization groups to apply privileges to those users, for like admin accounts or standard user accounts. Those group permissions can be configured to kind of mirror for that local account creation. All right, so again, I know this slide has been repeated, but again, with everything we've announced at DubDub, here at JNUC, we're doing to make the best offerings for IT. There are a couple of things on this slide that we didn't get to cover, like the being able to do configurations with shortcuts, tvOS, as well as the watchOS management, which I know Jeremy mentioned during the keynote, but again is also very exciting. And we want to include this because it kind of follows up to the resources we want to give you as takeaways. So first up, we have our What's New document. It's What's New in Education and Enterprise. This is a great summary of everything that we've announced, from management to security, specific features within the operating system, and this is all available on Appleseed for IT. Additionally, I wanted to call out our Platform SSO document. So this is going to be critical if you're wanting to implement Platform SSO. We barely scratched the surface on what it's capable, and this document is going to be a lifesaver. There's so much information in here, and it is also available on Appleseed for IT. Even though it says it's a developer documentation, you can find it there. And for those who don't know what Appleseed for IT is, hopefully you all do, but if not, this is a site where you can get ready for upcoming operating systems, get an overview of things we've announced, but then also we have some great takeaways like test plans and like some of the documentation I just mentioned. Also, I have to call out, since we're talking about Zero Trust, the macOS Security Compliance Project on GitHub, or the MSCP. Using this for device hardening, doing trust scores, right? Such a great resource, and we want to make sure you're taking advantage of it. If you have any compliance needs in your organization, this is the ultimate resource. Next up, we have our Apple Platform Deployment Guide. So this is a reference, kind of like a technical documentation of all of the topics that we've discussed. So if you attended the Deploying macOS Sonoma, a lot of that information is going to be available here. So again, it's just another great resource. And then my favorite document is our Apple Platform Security Guide. There's a wealth of information. If you've ever had any questions around our device's security, if you want to know more about the secure enclave and the way we do our cryptographic processes, a lot of that is going to be in here. And then finally, we have our user guides for Apple School Manager and Apple Business Manager. So this is going to help you navigate anything around those two interfaces, or if you have any questions. And that is it. So thank you all for attending, and hopefully you have a great JNUC.
We'd like to thank Apple once again. There is no Q&A for this, so please, thank you so much for coming to the session. Jamf would like to thank Apple for doing that. If you have any further questions, please reach out to your Apple account team. Thank you so much, and enjoy your JNUC.